So as you can see in this geometry, there is inner cylinder and there is outer part. So basically this is solid part and outer part is overall fluid part, and there is inlet. This is inlet where the fluid will enter inside the computational domain, and then there is outlet. So this one is your outlet, and the remaining surfaces I have defined as the wall, basically the no slip boundary conditions there. This inside cylinder will have volumetric heat generation. The unit will be watt per meter cube, and liquid, which is outer part, basically the enters and extract the heat from this solid part, and it can go to ambient or somewhere else. So that's the overall physical or computational domain for this tutorial or conjugate heat transfer simulation. We will also discuss how to create multi-body geometry. For example, we have inner cylinder and outer part. So basically we have multi-bodies for this tutorial. We will also discuss how to unite or subtract multi-bodies, and basically we will talk about Boolean operation and different component of Boolean operation like unite, subtract, intersect, and I will not cover this part in this tutorial, but maybe future I can create video on this part also. We will also discuss about how to create interface between solid and fluid. Basically we will talk about surface topology and how to connect interface between solid and fluid or different bodies. So for this tutorial I will use fluid flow fluent with fluent meshing, because using this option we can create advanced meshing that can be utilized for fluent. So let me give a name, conjugate HT, and to avoid any problem let me first save it, and okay, conjugate HT, yeah, and conjugate HT. Now I will start geometry tool, and I will use the design modeler for creating geometry. So let's start and wait a little. And for this part I will create an inner cylinder and outer flow field. So for inner cylinder I will use geometries. I will drag it little bit here, and first I will go to sketching, and then I will use this circle option, and before that let me modify the unit, and then let's create a circle of certain dimension, say okay, say 10 mm. Let me do little bit of adjustment, and then I will extrude this part, okay, to both the direction around 15 mm, exactly 15 mm. So this is the inner part, and for creating another body we need to perform a very important operation before creating another body, and that operation is called the freeze operation. So just go to tool and click on freeze, so it will freeze this body, and then you can create a separate body along with this. So for that I will again use the same plane, gx plane, and then I have to create a new sketch. Here you need to keep in mind that you should not click on this sketch and just start another sketch. It will create error, so go to this and create sketch. So for this part I will create a rectangle. So let me create a rectangle of, and let me give it certain dimension. Okay, so okay, this let me give 15 and yeah, 50, and it was 30 and 100. So this rectangle you have created. Now you have to extrude this rectangular part, and for this extrude operation I will again use the symmetrical both side, and I will completely enclose the inner cylinder. For this tutorial you have to just click on generate. So if you realize you have two bodies and both are solid part here, so let me give a name, because first I have created the frozen part, and that was the cylinder, and then this, let's say it's outer part, and this is just for convenience, because then we can perform different operation very easily. And before going ahead, let me first show you how it looks inside. So you can create a sectional plane, and you can see what is inside. So yeah, so if you hide this cylinder, let me hide it, you can see that that is not a hollow part, but a continuous part in place of cylinder. So the bodies are basically overlapping here, and if I just hide outer part, let me hide it, so you can see only inner cylinder. So basically this part is the overlapping part of outer geometry inside inner cylinder, so we need to remove that part, or we can perform other operations using the boolean. So I will explain all those options. So first let me show all the body, and then we have to go to create and boolean. So before going ahead, I would like to specify that this option will only be available if you have multiple bodies. If you have single bodies, then this option will not be available. So first create multiple body, and then you can perform the boolean operation. So let me just click on this boolean, and you have multiple options like here: unite, subtract, intersect, and imprint faces. Unite is very straightforward. It will merge both bodies and create a single solid part, or single part basically. So you can explore that part. I will not give much attention to it for this tutorial. And there is intersect part. So this part is basically about the intersecting region, so overlapping region basically. So let me perform this part first, and then I will come back to subtract, which is basically important for conjugate heat transfer for this tutorial. So for intersect part, they are asking to select bodies, and if you select bodies, like you have to select multiple bodies for this operation, and it will be about overlapping part. So it is asking preserve tool bodies, and if I click yes, so yes, So basically it has created a new outer part that was overlapping initially. And if you choose another operation, like instead of yes you just say no, so you will have only overlapping part as a single body which will remain, other part will be removed. So that is the meaning of this operation here, that is intersect operation. So after this there are two more operation like subtract operation and imprint faces operation, and for this part of tutorial I will not cover this imprint faces operation because the geometry that is required might be different to explain this operation. Just go to subtract, and then it is asking for two options, target and tool body. We need to select target body and tool body. So target body, you can imagine it as a knife and you are going to use to cut certain material using the knife. So you can remove knife completely or you can keep the knife there after operation. So both options will be there for this subtract operation. And the target body, let me select the target body as outer part and tool body as the cylinder. And here let's say you don't want to preserve tool body. Tool body is your this inner cylinder part, so let's generate it. So it has removed the tool body and used that tool body for subtracting some part of this target body. That's the overall meaning of this operation, subtract operation basically. So let me change that option to yes, I want to preserve tool body also. And then you can imagine you will have right now, even if you have both the part, but let's say you hide this part, so you can see the hollow space. So now the geometries are not overlapping but they are separate with each other. So that's what we have performed through this boolean and subtract operation. So that is very important for conjugate heat transfer part, which I will explain in the later part of this. If you are here for learning boolean operation and this part of tutorial has been helpful to you, please hit like and subscribe button, and also you can share this video with your friends or colleagues. Let me first show body and let me define it as a solid and the outer part as a fluid. Also let me see whole body, and now I will define the boundary conditions. So before that let me see the isometric view. Select this plane, go to named selection, apply, let me define it as an inlet, and click on generate. Then let me define these outer surfaces, four surfaces as outer wall, and the remaining part let me define it as a first I need to click on this generate option, and then let me define it as outlet and just hit on generate option. So you have created inlet, outer wall and outlet for the next part of this video. So finally we have created this geometry for CFD simulation, and we are going to utilize this geometry for generating mesh or meshing part. So we have done the geometry part. Now we will start meshing. So just click on mesh, click on edit, yes, and then you can choose the number of processors and solver option. So I will choose let's say 6. That can depends on your computer also, and I will choose double precision. So just click on start. So here you have to click on import geometry, and then since it is already created in ANSYS Workbench using the geometry option, so you just have to click on import geometry. Now it is asking that add local sizing, and for this part I would like to add local sizing basically near to solid fluid interface. So I will click yes for local sizing, and I will choose you can change the name of local sizing whatever you want. So I will keep it default, and instead of face I will select yeah, I will keep it default also. And for this part I will select inner cylinder to create refined meshing near the interface region. So just select cylinder, and more importantly I will change the sizing here to 500 micron. So I want the mesh size near the interface to be around 500 micron, and it can increase away from the interface accordingly. So I will choose this option and just click on add local sizing. After this option you have to generate surface mesh. For generating surface mesh there are two important parameters, minimum and maximum sizing. So you can change these numbers, and I will keep default for this case, and I will just hit generate the surface mesh. So now next option is describe geometry. So basically our geometry consists solid and fluid both. So I will choose the third option, which tells that it consists of both fluid and solid and or white. So I will choose this option appropriately. And also apart from this this option, do you want to apply surface topology, and I will choose yes for that, because I would manually like to create interface and apply surface topology for this case. So just hit describe geometry. Now there are two methods for connecting interfaces. The first one is joint intersect, and the second is interface connect. In case of joint intersect, it will detect interface zone and it will connect automatically. In case of interface connect, we need to specify the interfaces which we want to connect. So that is the meaning of these two methods, and for this case I will choose joint intersect and just hit apply share topology. And for boundaries you can check the boundaries, because these surfaces or the named selection we have already created in ANSYS geometry option, and you can check the boundary type and change if you want. So for my case these are exactly what I want, so I will not change any boundary type, and I will just hit update boundaries. So now it is asking to create regions, and for my case the estimated number of fluid regions going to be 1, because the outer flow is airflow for this tutorial or conjugate heat transfer case. So I will just hit on create regions, and then there are two regions, cylinder and outer part. So by default it has taken correctly, but sometimes it might not take correctly, so you need to just drag your mouse in this region to see which part is actually which part, and you can change the regions. And sometimes the regions are created by default due to some reason. So again you can drag your mouse on this and can check the region, and you can also change if you want. So I will just click on update regions, and the next option is the boundary layers. For my case I would like to add boundary layer, but not on wall, but solid fluid interface, because that will influence the heat transfer significantly from solid to fluid. So I will just hit on add boundary layers. And the next option is we have to create volume mesh. For that I will choose polyhedra meshing, and I have created a video where I have talked about different kind of meshing, basically these kind of meshing and their advantages and disadvantages, and you can watch that video, and the link is also given in description. So for this part I will choose polyhedra mesh, and you can change the maximum cell length and growth rate also if you want. I will keep default for this case and just hit generate the surface, generate the volume mesh. So here we can see how the meshing is actually created. So it is really beautiful near the interface, and interface is properly connected, and we have sufficient refinement near to the interface using this technique. So that is for this meshing part. And now one more option you can use is you can see your meshing on different clipping planes. So just by dragging it you can see the mesh on different planes. So that's for this meshing. Now we will close this and we will go to solution stage. So for the next part of the video, which is setup, solution and results, I have another video which utilize the SpaceClaim for geometry creation. But this later part, like setup, solution and results, are identical for both the cases. So you can watch that video, and the link is also given in the description. And also those who have not subscribed to my channel, please subscribe to my channel, because it gives me motivation to create more educational content like this. And also please like this video and share it with your friends and colleagues. Thank you for watching, and thank you for your attention.